Have you ever pondered about the vastness of the universe and wondered how it all began? Well, the answer lies in the concept of the expanding universe. Picture this. The universe that we live in started from a single, infinitely dense point known as the singularity. It's kind of like the ultimate dot from which everything we know has emerged. Since that moment, which we commonly refer to as the Big Bang, the universe has been stretching and growing, much like a balloon being inflated. The galaxies, stars and planets we see today, they all have their roots in this cosmic expansion. The Big Bang theory, as it's called, is the most widely accepted explanation for this ongoing expansion. It's the cornerstone of modern cosmology, a theory that paints a picture of a dynamic, ever-evolving universe. So, the universe, as we know it, started with a bang, not a whimper. But how do we even know this is true? You might ask, what's the evidence behind this Big Bang theory? Well, there are three main pieces of evidence that support this theory: the observed redshift of distant galaxies, the abundance of light elements, and the cosmic microwave background radiation. Let's dive into the first two. First up, we have the observed redshift of distant galaxies. This is essentially a fancy way of saying that when we look at distant galaxies, the light they emit appears red. This is due to the light waves being stretched as they travel vast distances, a phenomenon known as the Doppler effect. In the context of our universe, this redshift is significant because it indicates that the universe is expanding. The galaxies are moving away from us, and the farther away they are, the faster they're moving. This discovery by Edwin Hubble in the 1920s was a game changer. It was the first real, tangible evidence that our universe began from a single, incredibly dense point and has been expanding ever since, the very essence of the Big Bang theory. The second piece of evidence is the abundance of light elements. In the moments following the Big Bang, the universe was extremely hot and dense, a perfect breeding ground for nuclear reactions. These reactions led to the formation of the light elements, hydrogen, helium, and a smidge of lithium. Today, when we look out into the universe, we see these elements in the exact proportions predicted by the Big Bang theory. This isn't just a lucky guess, it's a powerful validation of the Big Bang model. These pieces of evidence strongly support the Big Bang theory. But there's another crucial piece of the puzzle: the cosmic microwave background radiation. What if I told you that a relic from the Big Bang is still observable today? Yes, you heard it right, and it's called the cosmic microwave background radiation, or CMB for short. Now let's dive into what this really means. Picture this. You're staring at the night sky, captivated by the vast expanse of stars and galaxies. But what if I told you that there's more than meets the eye, that there's a faint radiation permeating all of space, invisible to the naked eye but incredibly significant? This is the cosmic microwave background radiation, the afterglow of the Big Bang. The CMB is a cosmic whisper from the distant past, a snapshot of the universe when it was just about 380,000 years old. Before this time, the universe was a hot, dense plasma where light couldn't travel freely. But as the universe cooled and expanded, protons and electrons combined to form neutral atoms, and light was finally able to move unhindered. This light, stretched and cooled as the universe expanded, is what we now detect as the cosmic microwave background radiation. Now, you might be wondering, how do we know all this? Well, it's all thanks to two brilliant scientists, Arno Penzias and Robert Wilson. In 1965, while working with a large antenna, they stumbled upon a strange noise that was uniformly spread across the sky. After ruling out all terrestrial sources and potential errors, they realized that they were observing the CMB. Their discovery, which earned them the Nobel Prize in Physics, provided strong evidence for the Big Bang theory, reinforcing the concept of an expanding universe. In essence, the cosmic microwave background radiation is a cosmic time machine, offering us a glimpse of the universe's infancy. It's a testament to the Big Bang, a silent yet powerful affirmation of our universe's fiery origins and a constant reminder of our cosmological journey. So, the cosmic microwave background radiation is like a snapshot of the universe just after the Big Bang. Isn't that fascinating? So, what does all this tell us about our universe? Well, It's time to weave together the threads of our cosmic tapestry and see the bigger picture. Firstly, we delved into the concept of an expanding universe. We saw that the universe isn't just a static backdrop, but a dynamic, ever-evolving entity. It's like a loaf of raisin bread dough in the oven, steadily rising and carrying all the raisins along with it. Except in this case, the raisins are galaxies, and the dough is the fabric of spacetime itself. This expansion is a key piece of evidence supporting the idea of the Big Bang, the event that kick-started the universe as we know it. Speaking of the Big Bang, we then moved on to explore the evidence that supports this theory. We discovered the notion of cosmic redshift, which is the stretching of light waves from distant galaxies due to the universe's expansion. This phenomenon provides a sort of cosmic roadmap, allowing us to trace the universe's history back to its earliest moments. And then we ventured into the realm of the cosmic microwave background radiation. This faint radiation, a relic from the universe's infancy, is the afterglow of the Big Bang. It's like a baby picture of the universe, offering us a glimpse into a time when the universe was just 300,000 years old. These concepts, the expanding universe, the Big Bang, and the cosmic microwave background radiation, all come together to form our current understanding of the universe. They tell us that our universe had a definite beginning, that it has been expanding and evolving ever since, and that its earliest moments are still visible to us today. The universe is vast, mysterious, and constantly expanding. And every time we look up at the night sky, we're witnessing the echoes of its fiery beginning. So keep exploring, keep questioning, and remember, we are all made of star stuff.